The reason we are adding batteries to the regions in our microgrid is to develop a buffer battery solution. So the buffer battery separates two AC sources using a DC bus bar and a battery. So what that actually looks like is we have inverters that are connected to the grid, and we have battery connections from those inverters. Then we have inverters that are connected to the on-site loads. And so to get power to and from the grid, it flows through the batteries. Now you're thinking maybe there's some inefficiency there. Why would you want that? A couple reasons. First reason, it totally eliminates the possibility of drawing or selling more than 24 kilowatts from the grid. And so if you were looking to develop a community or a commercial structure or a power town at the edge of the grid, and the utility can only deliver 500 kilowatts, but you need 2 megawatts, you can go ahead and say, hey, I'll take that 500 kilowatts. I will put an inverter on the grid, and then off-grid, connected to my DC bus bar technology, I will have generators and inverters, solar and inverters, and an inverter for my battery. And that solar could even be directly on the bus bar with a DC-DC converter. And so, yes, you do lose a little bit of efficiency if you're buying and selling substantially from the grid, but it lets you develop where you otherwise may have to spend lots of resources developing the grid when you could have invested in your own power plant. And then the other thing it does is it totally isolates your off-grid system from your on-grid system's waveform. An inverter makes a beautiful waveform, a generator less so. And the grid, where I'm at, is pretty decent, but in some parts of the world it is all over the place in terms of frequency, in terms of voltage, in terms of frequent outages, unplanned outages, planned outages, brownouts. And so in a scenario like that, your sensitive power electronics would prefer the stable output of an inverter to the unreliable output of a bad utility connection. So those are just two reasons. And as our battery voltage increases, we will see a less efficiency loss transmitting between these two systems. And we're developing our control scheme so that all of our distributed energy resources, including our pets, our solar, our electric vehicles, can integrate into the DC bus bar here, which lets us keep DC as the heart of the system, long-term develop DC appliances, DC integration between buildings, and short-term, we can connect AC loads and sources no problem with inverter technology.